So, hello all. I hope you all are pink of health. Myself Yash, and this is my first YouTube video which will help beginners in making some cool projects based on Python, which will be totally beginners friendly. And this would be a short video but will going to help you a lot. So before starting the video, let's see what we are going to make today. Today's project is cartoonization. Yes, you heard it right. We are going to make cartoons. Means you can convert any of the image and can add cartoonic flavor to it. You can apply this over your friend's photograph or can experiment by taking your sister's photograph. Okay, so this would be a fun. So let's know the need behind it. So most of the cartoonizer application in the market are not free. In order to get basic cartoonic effect, nobody wants to spend money over it. That's why Python make it more convenient by using its package called OpenCV. We can do that. So building this project has two important things. First one is bilateral filter and second one is edge detection. Bilateral filter, this will reduce color palette necessary for the cartoonic look, and edge detection allows production of bold silhouettes. So let's just know what we are going to do. So the algorithm behind this is we are going to apply a bilateral filter to reduce color palette of the image. And then we are going to convert that original color image to grayscale. Then we will apply a median blur to reduce image noise in the resultant grayscale image. And we're going to create a mask using adaptive thresholding. Then we will combine the image and we'll get the required amount of required image. So let's start coding now. So first of all, we are importing the libraries first. Let me comment out this. Okay, if spelling is wrong, ignore that. So import, for that you first need to import some basic libraries. NumPy as np and import cv2. All right, so libraries have been imported. Next we are going to read the image. So how we are going to read the images, we will going to take an variable. Inside that we are going to write the code cv2 dot I'm read. Okay, and now you can put the name of that image, like in my case, oh sorry, not that. So in my case it is china.jpg. Okay, so this is in my case. Now we'll work on the edges of the images that we have used. So another variable I'm taking is a gray. Gray is equal to cv2 dot cvt color. Image is a variable that we have used. cv2 dot color underscore bgr2 gray. All right, so what is cvt color? So this is a method which is used to convert an image from one color space to another. So for your knowledge, so there are more than 150 color spaces conversion methods in OpenCV. All right, so we are using gray variable again, and inside that this time we are going to use cv2 dot another functionality that is called median blur. Make sure that you are using the correct way of writing those methods name. All right, like if there is a capital B, you must be writing capital, and if it is small, then you will be writing small. Otherwise, it will fire an error. All right, gray, comma. So now what median blur does is, this is a linear filtering technique. As clear from name, this takes median of all the pixels under the kernel area and replaces central element with this median value. This is quite effective in reducing certain type of noise because we are taking median. The output image will have no pixel values other than that in input image. So here 5 is the kernel size of the image that we want. Next up, moving towards the edges, and edges would be again cv2 dot adaptive threshold, writing the name gray comma 255 cv2 dot adaptive underscore threshold. It's not that threshold, it's thresh underscore mean underscore c comma cv2 dot thresh. Okay, sorry, I just left the tab on. This would be small cv2 dot thresh binary comma 9 comma 9. Okay, so what we have done, adaptive thresholding decides how thresholding value is collected. So adaptive threshold here adaptive threshold, this means the threshold value is the mean of neighborhood area. So let's know what it is. So gray is the source, 255 is the maximum value, and adaptive underscore thresh underscore mean is the adaptive method, and cv2 dot thresh binary is the threshold type, and then 9 is the block size, and another 9 is the constant. So maximum value is the value which is assigned to the pixels. All right, this worked. Now for cartoonic effects. Okay, so we are taking a variable called color. Inside that we want cv2 dot bilateral filter. As I told you earlier, it would reduce the color palette. So putting the image as the source, 9 comma 50 comma 50. So what it is, it's the destination, another one is the diameter, another one is sigma color, and then sigma space. Okay, this what the content inside these parentheses represents. Next one is we are taking cartoon and cv2, sorry, cv3, cv2 dot bitwise underscore and color. This is the source. Again, color mask is equal to edges. Make sure you're writing it correctly. Otherwise, this would create error. So now bitwise and it's a function that performs bitwise and processing, like the end of the values for each pixel of input images, source 1 or source 2 is a pixel value of the output image. Now we are reaching to the final part of the project, which is cv2 dot am show is a functionality again, uh, image comma image. This is the source, and this under the quotes is the name of the window that would open, and that window's name would be image. Another we are taking is cv2 dot I'm show, sorry, I'm show edges. So I'll be displaying you all the images separately, all right, so that you could differentiate either is there any changes there or not. So cv2 dot I'm show This would be the uh, cartoon, comma, uh, all right, this worked. Now I'm cv2 dot weight key 0 and cv2 dot destroy all windows. So I'm running my kernel again. It would take yeah, it's ready. So let's do it again. Everything is working fine. So here's what we have created. This is the original image that we have. This is the edged image that we got, and another one is cartoonic image that we have. So this is the final thing that we wanted to do. We can create such kind of thing with other images as well. I took this image as a part of my project, and thank you for watching it. Thank you guys.